Hello friends, this is Professor Dr. G.S. Wajire from Department of Electronics, Sri Shivaji College of Arts, Commerce and Science, Akola. Friends, today's topic for lecture is RS Flipflop and clock RS Flipflop. Before going in detailed discussion about flip-flop, let's go through its basic knowledge and basic concepts. So we can say the flip-flop is a basic memory element or basic memory circuit. Memory circuit in the sense it can store the data. It is bistable multivariator and has two states, and these two states both are stable, or we can say these are fixed states. It is also called as latch because the data get fixed or locked in this circuit. That's why it is called as latch circuit. Next, it is used to store 1-bit digital data, we can say binary data, and of course that bits may be either 0 or 1 bit, which is stored in this flip-flop. It has two outputs, and these both outputs are complementary or opposite with each other. Next, we can say a flip-flop can be constructed using NOR or NAND gates, and as you know, these both gates are called as universal gates. And finally, we can say the flip-flop is a basic bistable digital memory element widely used in registers, counters, memories, and many type of logic control circuits. Now come to this topic, RS flip-flop. Here R means reset and S means set. That means here we can reset or set the output of this flip-flop. So in this particular case, there are two inputs. One is called as reset input and another is called as set input. And similarly, it has two outputs. One is Q output, which is main output, and second is its complemented output, which is called as Q bar. This RS flip-flop is constructed by using two NOR gates. First is this gate and second NOR is this gate. So before going in detailed discussion about this RS flip-flop, you are supposed to know the basic function and truth table of these NOR gates. And here, for your sake of simplicity, I have shown the output of this NOR gate. Here it is first input, here is second input, and of course this is output. Here, if we observe carefully this truth table of NOR gate, then it is seen that when both inputs are 0, 0, then only the output of NOR gate is 1, and in all other combinations for input, the output is always 0. That means from this remaining 3 inputs, we can say that if any one of input is 1, then the output of this NOR gate, it is 0. Now let us discuss about construction and working of this RS flip-flop. If we see carefully, the output of first NOR gate, it is connected to input of second NOR gate, and same happens that the output of second NOR gate, it is connected to input of first NOR gate. And exactly due to this such property, this Q output and this Q bar output, they are opposite of each other. So let us consider the case that this Q output, it is suppose 0 and its complement output is 1, and this is its stable state. Now from this state, if we want to set the flip-flop, that means we have to make the main output as 1. So for this, we have to connect the input conditions as like this. Here, set input, it should connect to 1, and reset input, it should connect to 0. So for this condition, come to the input status of this lower NOR gate. Here this first input it is as 1 and second input it is taken from this output and it is 0. So for this lower NOR gate, one input is 1 and other input is 0, so that its output is 0. So its output is 0, we can show here. Now come to this upper NOR gate. See, its one input is 0 as R input and second input it is going to 0 from this output of second NOR gate. So both inputs are 0 0, that's why its output it is 1. So recently we can say this is its recent output as 1. That means now recent output, this main output is 1 and second complement output is 0. So in this case this flip-flop is called as set. Now let us come to next condition. Say this condition where we need to reset this flip-flop. So we have to apply the input conditions as S0 and R as 1. So let us take this reset condition of S as 0, I use different color, and R as 1. And let us see the output of second flip-flop. So for second flip-flop, first S input is 0 from this side and second input it is coming from output of upper NOR gate which is 1 and going to connect to input. So for this input conditions, the value of R is 1. So 1 is connected to input of this gate, and as per the definition, if any input is 1, then its output becomes 0. So latest output of this gate becomes 0, and obviously this 0 is connected to input of this second gate and its one input is already 0. So for this gate both inputs are 0 0, so its output, recent output is 1. That's why we can write here recent output as 1. So here for this condition we can say this flip-flop is now get a reset. Similarly, if we apply this condition of both as 0 0, then for this condition there will be no change at its output. So both outputs it will remain same as in last case. So this output, such condition, it is called as no change condition. That means output are not going to change. And come to final state, final condition, where we have to apply this condition of both S and R, they are 1. So during this condition we are going to apply this R input as 1 and this S input as also 1. That means reset and set, both inputs are going to connect to logic 1, and of course this particular condition it is going to violate the basic definition of this flip-flop. That means both outputs as Q and its complement, they are going to become uncertain state, and that's why this uncertain state it is not allowed in case of flip-flops. This particular case it is also called as invalid condition. It is also called as undefined condition, which is not allowed. It is also called as unpredictable condition, which is ambiguity in meaning. So it is also called as meaningless condition. It is also called as absurd state and also called as racing state. And due to all this uncertainty, this state is basically known as forbidden state, and this state is always avoided in case of RS flip-flop. Here in this slide the same circuit is shown, taken from different book. Its truth table is here, and one more important thing, the symbol of SR flip-flop it is shown here. It is having two inputs as S input and R input, and having two outputs as Q output and its complemented output. Now come to next topic. It is gated latch flip-flop, or even it is called as clock RS flip-flop. In a sequential system, it is required to set or reset the flip-flop in synchronism with the clock pulses, and this is achieved in case of clock SR flip-flops. The SR flip-flop is modified clock SR flip-flop by adding these two gates, here this one and second this one, along with the clock signal, or it is also called as enable signal, and remaining two inputs are same as S input and R input, and same happens with output as Q output and its complemented Q bar output. If we come across its truth table, then come to first condition that both R and S are 0 0, then the output is not going to change. That means it is last state, which is indicated as Qn minus 1. The second condition that indicates R as 0 and S as 1. That means output is going to set, which is given as this condition as output is 1. If we come to next state as R as 1 and S as 0, then this is called as a reset state, where the main output of flip-flop it is going to 0. That means this is 0 and this is 1. And as usual, if we come to last state as both are 1 1, then already we have discussed this is called as a forbidden or not allowed condition in case of flip-flops. And of course, in all these input conditions, the enable input or clock input, in all cases it should be 1 compulsorily. And this last figure indicates the logical symbol of clock RS flip-flop. As usual, it is having S input, R input, one more as clock input, and two outputs as Q output and its complemented Q bar output. So I think we should stop here. Thank you very much.